Okay, it's time to talk about another very important subject when it comes down to working with custom characters. So right now I have this mannequin character, and if I pick up any of those weapons in our project, I can equip them. We have IK on the right and left hand, and it is being driven by the animations. So the left hand position, the only IK I'm running, it's just following the copying the right hand IK, so all those sways, this, those sways, and that's it. But the placement of the right hand and the left hand, if you eject, is being done by animations themselves, and this is as designed for this mannequin character. And if you buy any marketplace asset, you will find that the crosshair alignment and everything is being done within animation. So if you import a custom character that has different height, different shoulder size, different length of arms or legs, you will have a very bad time retargeting those animations. And normally if it's running the same skeleton, you can just share skeleton between characters and share animations between characters without any retargeted needed, because if you go here into the skeleton itself, so let's go into content AGR, character, mannequin character, mesh, okay, this, right? So retarget options here, they're not being baked when you are retargeting animation. When you are retargeting animation from one asset to another asset, what actually happens is you transfer the animation information from bone name to bone name, and that's it. You're not really changing how the animation is being run, because this retarget settings you can change on runtime. So for example, I already following my previous tutorial imported a G8 male zombie test character here. So if you go to the skeleton, you see how big this guy is. And now if we change preview mesh to our zombie, you can see that he's actually a bit smaller. He has smaller hips, smaller shoulder. He's a bit less tall than the actual character we were using. Then the mannequin, he has smaller hands. So what you will find that if you just run animations as is right now, if you just do a preview animation, let's say idle, let's say this one, it will be actually a bit off. It will not work as intended, honestly. And yeah, it just won't work. So if I swap my main guy here right now, so this is my character, and I just swap the mesh to my zombie, I will show you what will happen. So we are already running a lot of IK, and this IK settings will make some things work and some break completely. So for example, already our settings are adjusting our feet position, but we are still floating above the air, which we can see clearly here. And if I eject, you could see that this guy has feet bone position marked in the same place that mannequin had, but mannequin had different foot size. So the ankle of the mannequin was a lot higher than the ankle of this guy, so he's floating above the air, and because of that he's now squatting because the pelvis is in the same location. His arms are actually shorter than the mannequin, so he's stretching them up a lot. And if I pick up any weapon, if I just go into this guy, and by the way I can also see his nose, if I pick up any weapon and we'll repair everything, if I equip it, you can see that my hand is now going through the weapon and my ADS is absolutely broken. It's not aligned with the camera, and the camera is in the head bone directly without any adjustments. So we can fix it by many ways, but the way we want to fix it is we want to be able to read this animation information directly and use it here. If I change weapon to this one, you can see that my hand is completely missing the weapon here, and ADS is even more broken. If I eject, you will be able to see that I am holding the gun absolutely differently than I would normally. So how to fix all of that? we're going to have to do two things. One of the fixes will be really easy one. We'll just go here into our skeleton. We're keeping this animation scaled and animation scale just as it was. Everything is skeleton, so the skeleton proportion is driving, like the animation is just driving the rotation of the bones, but it's not driving the location and scale of them, so they are not being stretched. So this guy is not stretching anything, he's just using skeleton proportions. And if we change this, for example, for shoulders, like you have this weird angle of the shoulders, we can go to clavicle, let's say R, this one, and we can change settings for it. And this is like, if you go into animation, this is exactly where the animation was for this. So this is how short the clavicle is on the mannequin, but this guy has longer clavicles because he's just skinned differently. So also his spine setup is different. So like this is spine 1, spine 2, and I think this is spine 3. Yeah, so this is already neck. So this is neck bone. You can see how big it is. And this is the spine 3 rotation. So this is spine 3, this is spine 2, and this is spine 1. Never mind. So if we move clavicle here, he's completely destroyed. So if we go into skeleton, this is just being driven by the skeleton itself. And if we go from this clavicle to animation scaled, it will take the animation value, but it will scale in comparison to the skeleton setup. And if we go into animation relative, it will make a relative rotation. So it's taking the rotation from the animation, but it's keeping the scale from skeleton. And if we do just oriented scale, it will just take oriented scale, but it will keep the location from skeleton. So what we want to do is just completely go with skeleton. We want to go with everything as skeleton, just like this. Just save it, and only adjustment we're doing is here in the IK foot root, and we're going to set all of this as animation relative. And animation relative means that it will just make a relation between the difference of our mannequin and our character, and just drive it here, and this will help us to keep foot on the ground. So let's save it. Let's save it, let's go back here, let's hit play. And now if I eject from this guy, we have already contact with the floor. And now I think we could even make it better. Like this is already contacting, but if we go from animation to, no, not this one. This was relative and scaled. Okay, this won't work. So let's make it, yeah, I think relative will be the best. So just this, and so he will have exactly same amount of contact as our character was. So our capsule was 90, I guess, and our mesh is minus 90. So he is getting contact on the bottom of his feet with the ground. We could adjust this even more, but this is okay-ish, if you would ask me. So he's getting contact here. Here it's like maybe half a centimeter or less. So we could just move the entire character a bit down, like barely, minus 91. It's always better to have him just a bit more synced in, or this might be actually how our IK system is placing our legs. Oh yes, I think this is the foot IK. So it doesn't matter if we move him 1 centimeter down or not. Let's just then keep it minus 90. So this is just some foot adjustment that we're doing in our anim graph. So let's go to the core anim graph. So here where you have foot IK, we could say that we need to do offset feet position, and let's say -1, and let's do it same here, just -1, compile and save, and now he has more contact. So this was just IK. So the initial foot position is being driven by a different node, but the contact with the ground is being driven by the animation node itself, by the power IK. So we already fixed fit. Now let's fix the rest. So where we are fixing everything, we'll be fixing it here in this node, which is called AGR IK solver. And you can just copy the logic that I'm going to put in here into your own anim graph. You don't have to use my logic. You don't have to use it at all. This is just an example solution of a complete framework system that we are working on in the tutorials. But you can follow these steps to improve your animation quality and placement of hands and everything in your own anim graph, in your own implementation, in any way you like. So let's get here. And currently it's very simple. We're going to delete this. We're going to delete this. We're going to delete this. This is all not really working for us too well. So right now it's just this. Okay, so let's start by preparing the asset. So I want to talk to you about virtual bones. I've been using virtual bones for just few things right now, like there is a virtual bone on the pelvis just to read this virtual bone rotation, so I know the ragdoll is facing up or down. And I have virtual bone for the left hand, which is the relation between right hand and left hand in animation, and this one is being used to in here right now. This being used to copy the relation of the left hand to the hand alt. So the left hand is following our IK right now. Even if the placement of the hands are broken, if I move right hand, you can see that the left hand is moving as well. So it's rotating and it's moving. It has no frame tearing because I am not calculating the position of the left hand based on the gun, and I'm not calculating it at all. I'm just using bone space translation between one hand and another. And how it's being done is just this virtual bone, it is parented to the right hand. So whatever I do to the right hand, however I modify it, if I move it, if I do whatever with it, then it will translate to this virtual bone as well. So any twist to the right hand will twist the left hand, but it will keep this relationship between them. But what we're going to do right now, we're going to delete this virtual bone completely. We're going to leave this virtual bone left elbow. However, oh no, we're going to delete this one as well. And we're going to add the new bones, new virtual bones. So what we need is our hand R. We have only one virtual bone right now, and this virtual bone is called weapon mount, and I am using it to mount weapons, obviously. And this one is the relationship between right hand and this bone right here. So IK hand gun, because most of animation packs, at least decent animation packs, let's see, pistol idle, for example. So this is Kobold's animation pack. So it is animating hand IK bones here. You can see them. So this is the IK hand root is here at the root, obviously. And then you have the first master bone, which is called the IK hand gun. And this is the bone that is being used to attach any props to it. For example, a pistol in this animation. And any good quality animation packs will use this bone, but some of them will not. like the one we were working in the FPS Pro Pack, they are not using IK bones, so they are just using sockets, and we will manage it with sockets, so you don't have to worry about that. So yeah, so we are just storing this relation. So if we do any IK on the figure, this IK handgun would still stay in the same position. So if we, for example, use IK to lower this guy, or do anything with it, the gun would disalign with hands. But with this virtual bone weapon mount, whatever we do to the entire silhouette, this virtual bone will always follow right hand, and it will store the relationship between the right hand and this gun before any IK was applied whatsoever, or any additive animations were added whatsoever. Which means that we will store this relationship after we do aim offset, after we do physics animations, whatever we do, it will be still stored here. So we are keeping this bone, this virtual bone. It will be used for our weapons, but we'll make a secondary bone, which will just go from hand R to hand R. And now we have a lot of sockets that we are using. And the problem with sockets is that you cannot modify socket relation and rotation at runtime. You can attach to this socket an object, and then you can modify the object at runtime by adding relative location or relative rotation to it additively, and you can move the gun so it aligns with the hands and everything. But if we add a virtual bone, we can modify it by IK at runtime a lot easier, a lot faster, and we can read a value, a variable to it, and if we do, then we can change it at runtime as well. So let's add a virtual bone from hand R to hand R itself, and we'll call it virtual bone. We can't change the VB, and it always has a space, and this is important. If you are copying the bone name, it will just copy this. You have to write VB and then space and bone name. This is the socket name per se that you are using in any IK, in any get socket rotation, get socket location, all of that. So we'll call it weapon secondary, because this is not our primary weapon mount. This is the weapon, or you know what, weapon direct. Okay, and now we need 1, 2, 4 more virtual bones. So we know that we attach our camera to the head bone, and from the head bone, animation has stored some information like this. Like hands are IK hands are using the animation, so you can see the difference. This is the FK bones of our character, and here is the location of the hand R and L in the original animations. Here, like this is the left hand where it should be, and okay, I can just pause it. And this is the right hand, the position of the right hand. And if we position left and right hand, the relationship between the head and those two would be perfect for our FP animation alignment. So what we need to do, we need to go here, just close this, find the head, add a virtual bone, and the target for our virtual bone will be our hand R. So this is now storing the translation between the head and the right hand rotation, but the parent to this bone is now head. So if head is being transformed in any way, it will be not matched with this bone, so IK hand right, because we move the head by our disproportion of the body, but this translation is being stored. And all virtual bones are being applied into the animation on the animation compression. So it's being applied before it hits all the retarget options. So this is the raw animation data. Just like in the IK bones we have raw animation data, here we also have raw animation data. So we can use this one and we will call it VB perfect hand R. Okay, and now what we're going to do is we're going to go from perfect hand R and we're going to add another virtual bone, because we can add virtual bones to virtual bones, and drive it to hand L. So where is it? It's here. So why we're doing it like this, why we're doing it not parented to right hand, because we could, it's because we want to manipulate the perfect hand R rotation and position, or the head rotation and position, and I want it to be applied to the entire chain of hands, because we know that our hands in first person perspective, they need to follow head. So here we'll call it VB perfect hand L. Okay, and we need two more bones. So we put this point, and this point is called lower twist. So this bone is the lower arm R. Okay, so now we need lower arm R to add a virtual bone to lower arm R to itself. And this virtual bone, now if we select it, is just this dot here. But it is moving with our elbow, so if our elbow gets dislocated by any reason, this one will follow it, but it will keep the rotation of this bone in it. And this one will be called perfect hand R elbow, or you know what, perfect elbow R. Okay, and we need to do the same for the left hand. So now we go into our clavicle L, and we get into lower arm, and we add virtual bone to our lower arm L, and we call it perfect elbow L. And we got everything we need. So we got the weapon one, we got right hand, we got left hand, and we got two elbows. We save this, and it doesn't change our animation, it didn't break anything, it doesn't cost us anything extra, because those bones they are, you know, just packed in the animation itself, and as long as those bones are not being animated, they are just following their parent, because that's what they are doing. They don't apply any extra costs to the running of this animation, and because they are actually bones, they can be used to run IK. So you can add springing to it, you can add some other stuff. So instead of applying this rifle to the back like we did and have it just stick to the back, we could make a virtual bone, apply it to the virtual bone instead of socket, and we could then add some springing, so it just, you know, animate a bit and look more alive when we are running. But this is for a different day and different solution. Here we are talking about how we can make this relation perfect. So yeah, you can see how the fit would be adjusted a bit, and yeah, let's go to our IK solver. So our IK solver needs to do a few things. First of all, we need to do a node called copy bone. And we need to say that our source bone is actually hand R. So if we manipulated our hand R in any way, we want it to be translated into our perfect hand R, but we don't want to translate everything, and by the way, we don't want to expose any of those because we don't need them. We want to just copy rotation. So we are copying just the rotation of this hand. However, we could actually manipulate the rotation in our IK system of just the perfect hand R, which we'll be adjusting in a second as well. So we're doing this, or you know what? Let's skip this one because we will update our hand sways. So we will skip this one. but we still have to modify bone. And what we need to do, we need to know how we have to modify. Okay, you know what, let's start with just IK. So I already talked about leg IK. So this is just a standard node for the IK system inside UE4, and it deals with the knee and rotation and everything for you, and you just copy those settings. It's just fine. You don't have to worry about it. It's just adjusting the position of the legs, not the actual IK aligning to the terrain, but it's adjusting the pose. So this is the hand L, which we have to do after hand R. So this will be hand L, and this will be hand R. So here the IK bone that we are modifying is hand R, and we are using an effector, which is our perfect hand R, and here we are modifying hand L, which is in bone space, and our effector is a bone, and it is perfect hand L. And I think that's it. So this should place our hands perfectly in the location of our original animation hands. So bone VB, left elbow, bone VB. Oh yeah, of course it's not. So also here, joint target, it has to be in bone space, perfect elbow R, and here it will be perfect elbow L. And what's the rotation? So it will be Y minus 10, I guess. Let's check. Okay, if I do minus 1000, so this is right hand, this one. Okay, so it will go like this, and if I go 1000, it will go backward, right? Yes. Okay, and if I go here, it would go down. And if I type here, it would go, I don't really know where. Let's check minus 1000. Okay, so this is okay. So what we need is 100, 100. So this is the target location, and if we don't go 100x, it will go here. So from the elbow directly towards the outside of the elbow at this rotation. So I think this will be fine. So we'll just keep it 100 here. And here it will be actually also 100. No, so 100 for this bone is different rotation. It goes this way. So for this one, it will be minus 100. Okay, so now it's just pushing the elbow to the elbow location that it already was, but it's taking account that maybe this hand is, you know, longer, for example, so the elbow is in different location. So it will then try to pull it back to the location. So as long as he doesn't have really giant hands, he will have the general same pose. And now you can see our virtual bones for the right hand and left hand. And yeah, that's it. We just save it and we go into our shooting range. And now if we play as our zombie, we'll pick up a weapon and then we can equip it. And you can see that my left hand is broken. I don't have my weapon sways anymore. But if I go into ADS, now my ADS is perfect. It is exactly as animation made it. and if I pick up the second weapon, it will be the same. The hand position is bad, but the ADS is perfect. And if I go and go out of the character, oh, okay, he's ADSing right now, so let's not. So if I go outside, you can see that his hands are broken, and his hands in general are a lot smaller than the mannequin. Mannequin has just like giant hands. And the gun is disjointed because the socket is using word space transformation between the bone location. It's not taking account of the bone scale, like how big is the actual hand in compared to mannequin. So the mannequin's wrist would end up like here. He has bigger fingers, so they would be like here. So you can see that this is the difference in size of their hands. But we have perfect positioning for our aiming already, right? But we want it to look good as well. So to look good, we have to do another thing. We'll go into AGR, Blueprints, and we need to find our interface. So this is the AGR interface, the common interface between each AGR object. And we have character interface, and we need to add a new function. And this function will be called get hands IK. It will be a character function, and it will not have any inputs, it will just have outputs. So it will be a fast pass function, and we'll say hand R, and this is just vector, so the location of the hand R, and we'll say hand L, it's also a vector, and then we'll say hand R alpha, and this will be float, and we'll say hand L alpha, and this also will be a float. Do we really need those two? I'm wondering, because we could drive those values. We could drive those values automatically. Let me think about that. Do we need those alpha? Do we really? Let's say we don't. Let's say we just need those two vectors. So we got those two vectors. Now we go back to our character, we recompile it and save it, and now in our interface AGR character we have this get hand IK. And now I already tested for this character, and I know that my proper hand IK positioning will be -1, 1, -1, and my hand L will be -0.265, because remember that hand L is child of hand R, so this is cumulative. So if I moved hand R already by -1, then hand L also moved by -1, but we can make some extra adjustment. Okay, and Y will be -2.495, and Z will be 167. And this value, how to find this value, it's quite easy. I will show you in a second. So let's go back into our core anim graph, and we need to make adjustment to it. And this is how you would do it in any anim graph that you have. You just go and try get pound owner. From it you say implement interface, and if it does implement interface AGR interface, in my example, what you want to do, you want to get IK, get hands IK. So you go here, and from those hands IK, you just make a promoter variable and say hand R. Should I rename it? I don't care. And promoter variable hand L. Just delete the space. Okay, so we are reading those two values live, and this is not a replicated value. We don't need it to be replicated because we might want to adjust those values depending on our viewpoint. So we just make this, and we say hands correction position. Okay, and we can collapse this. Hands IK. And just add it to our growing family. So we got two more variables here. So we go into our IK solver, and we need to add two variables. And this one will be called hand R, and it's a vector. And this one is hand L, and it's also a vector, and they are public variables. So they can be modified outside of this blueprint. And now we go back to our main graph. We go into our anim graph, and here, when we have our linked graph, we just expose those two variables we just created on the graph, and we just implement those. And you don't have to use a subgraph. You can just use it as part of your main graph. So whatever I have here in input pose is what you would just reapply directly from here into your local 2 component, and that's it. So we are pushing those two values now, and inside here we need to do a few things. So modify, transform, modify bone, and we need to do it 3 times. Why 3 times? I will explain in a second. So we know that in our animation we have 2 very important values stored and saved perfectly as it was. So one value is our hand's location in compared to the camera and the gun, and the second one is the weapon location as well. So we're going to modify all 3 of those aspects of our anim graph. So we just do this, and now this will modify our perfect hand R. Okay, and what it's going to do, it's going to take our okay, what do we want to do? We want to change translation, so it will be add to existing. We want to ignore rotation and ignore scale, and we don't need to expose them. So this will be just hand R vector, and this will just modify the position of the right hand in this very specific way that we want to modify hand R. So if we modify this, we need to move the gun as well, because if we move the hand, the gun is attached to the hand, which means that now our alignment is completely broken. So let's take this and let's modify the gun. So in order to do that, what we want to do, and same here, is to modify the weapon mount, and we want to modify the secondary that we made, weapon direct. So we want to modify both of them, and this one is modify weapon, modify right hand. And to modify weapon, we have to counter modify the right hand. So we take the right hand vector, we just multiply it by, well, not a float, integer will be more fit for this, so -1, and we now have inverted vector. We can also just invert vector, right? So in oh no, this is a different function. Okay, so this is just inverted vector, just multiply it by -1 and just apply it to both of those. Okay, so we got modify weapon. And now the last thing we have to do is just use this here. So no, and weapon to modify is perfect hand R, hand L, and we want to push hand L as the transform. So this is modify hand L. Okay, let's format graph, and we're not moving this because this is just the positioning, this is legs placement, and this is just the finish of the graph. Bam, bam, bam. And oh, okay, so here I forgot to change it. Add to existing, add to existing, and this is in component space, it's fine. And here also add to existing. So component space uses just the word space of this mesh, which is important for us because we don't want to do it in word space because we would have to deal with rotation as well, and we don't want to do it in bone space because each bone might have different axes. So like you see that right hand and left hand, the positive values for one is front and the other is back. So component space is the safest and easiest way to do it. So now we go here, we have those values, and if I hit play and I pick up a weapon, my hand position is adjusted, but my weapon is still a bit problematic, right? And the reason is because it's attached to a socket. It's not attached to a bone. So we have to change that, unfortunately, as well. So inside the weapon itself, we have to do a small modification because it cannot attach to sockets anymore. So we go into our examples, blueprints. I think it's in FPS Pro, and here we have the Pro weapon template. Attach component. So okay, so this is construction script. Okay, no, it will be in our anim notification, I guess, but it will be in this anim notification. So here, equip weapon. Okay, so this is doing equip next on our owner. So this is inside our character here. So equip next. Let's see how is it being done. So we're saying if our weapon is valid. Okay, makes sense. Get attached sockets, weapon ready. Okay, so for our weapon we have default values. So we have this weapon socket, FPS Pro socket. So we just copy it. And here, okay, we need to replace it with the one that we created here. So we have this virtual bone weapon direct. We need to edit it, copy it, go into our character, into this, yeah, into the character, add the weapon, but the character itself. So get attached socket, socket name. Okay, it's in the weapon, and it's here. So weapon socket holster socket, weapon socket. So we need to do virtual bone space and type in this. And once we've done that, we need to make sure that both our weapons are updated as well, because they might have overwritten this value, but they don't. And now they have the new default value. Awesome. Let's save everything, and if I run now, the weapon will be attached badly, but it will be a bit better when it comes down to following socket. Okay, so now it's like this, and if I go F8, it's a bit broken. So inside the weapon, we also have this on the ground. Okay, no, in our character, what else do? We attach to component. Now we are reading this popper socket. Then we're getting relative transform, and we are applying this transform. Okay, so here we have to go to our mannequin skeleton. We have to find our where is it? FPS Pro socket. So this was the location and rotation that we had in the socket, and we need to copy it. So copy, go here, and now once we get this rotation and location, we need to take location, add vector plus vector, paste it here. Come on, can I paste? Oh no. Okay, I have to just retype it. So 1 by 1. Oh, it's annoying. Just a second. Okay, and now relative rotation. Let's copy this one as well because we're adding relative rotation, and this plus delta rotator. Yeah, okay. So delta rotator is just applying to rotations. This, this, and should it set or should it modify? We're going to see in a second. So this, so we are not now taking the information from the socket that we had, and we are just applying it to the virtual bone basically. So let's go and run it. Now if I pick up a weapon, I have it completely messed up. Okay, and if I go here and I don't do this at all, just skip it, okay, then it will be like this. Okay. Okay, so what we need to do is not set relative rotation, but we need to go back here and say add relative, or just relative. Oh, it just set. That's going to be Can I add relative? No. Apply? No. I can add the actor word rotation and add word transform. Maybe this will help. Make. So I will take this location, this rotation, but I don't think that word will actually be in any way helpful, but let's test it. Definitely not. Okay. So let me think. And what if we just do this? This should just take socket. So if this just taking socket, our M16 should be working fine. But it's not. Because, okay, this was bone space. Can we change bone space? Okay. Can I swap bone space to that's annoying. Okay. Normally we should from the start with being parented to a virtual bone, but if we are already using socket and we got really far with this example with this socket, let's just keep it with the socket. It is possible to do it, will be just a bit more hacky. That's it. Let's keep it as it was. Let's get back our character. Let's just say that this is the new and this is the new, and that's it. So now once more, when we pick up a weapon, it is generally almost okay. So what we want to do here now in the character is not taking those two values of the socket, is that we want to add delta rotation. Well, we don't want add delta rotation, we just want location. So we want to do vector plus vector, and we want to get hand IK. It can be a function, can be an interface call, doesn't matter, because we're running it on self, so internally. And we're just taking our hand R, and then we are multiplying it by integer of -1 and applying it here, and this goes here. And now we basically made the same thing. So now the hand placement is adjusted. Like the hand is still, you know, not perfect, but the aim is perfect. So we can move the hand a bit forward and the gun a bit backward again. And you can, whatever transform you make to the hand, you have to do counter transform to the gun. Simple as that. And if you do that, the general first person perspective will be perfect. And you can see that my left hand is a lot better now, but we still have this problem. So this problem is probably because of the rotation. That's interesting. Oh, okay. Yeah, it's probably due to rotation. Oh, it's gonna be tricky. What can we do? And if we completely ignore this one? Well, no. Yeah, I know what we can actually do to make it work. As we would have to go to our hand IK and say first person. So this will be select, and it was if you are first person true, it's 0 0 0. If it's false, it's -1 1 -1. So we're not adjusting the right hand, we're now just adjusting the left hand. This is the easiest hack. So the right hand now is following the animation, so the right hand is messed up, but we don't care, we don't see it, we are in first person perspective. The left hand is the problem for us, so we are now adjusting the left hand. So we have this, and we got this problem. Let me think, what's the reason here? Let's go to our FPS. Okay, managed to find my error. Like this I won't really need, so I can skip it. It was just some small test. The error was that actually this vector application, it cannot be in component space because we're doing this IK after we are doing aim offset. So it has to be in bone space. That's the only difference. If it is in bone space, it is ignoring the rest of the bone's rotation. If we were applying this IK before aim offset, maybe that would be fine. But yeah, just remember, bone space. That's the difference. If we now go to shooting range, we can pick up a weapon, 1, 2, and we can now aim, and we can ADS. Oh, interesting. So I guess for it to work, like this is not always working. Let's just say that hand R is 0. Okay, yeah, now it's working. Like it wasn't reading properly for some reason. So yeah, this is how you do it, and now the left hand is placed as I intended, but now we lost this hand sway. So let's fix the hand sway. Let's go into show message. Okay, that's the usual. That doesn't matter. So let's go back to our AGR and the blueprints and MBP and hand sway. So the hand sway, how it normally works, it's applying some IK to the right hand, right? So there are two ways to do it. One is will be just taking this right hand sway and copying it to our perfect fit right hand. But the problem is that in this way we are moving just our wrist. So even though this sway is really cool and this is cool, we are moving with only our wrist. So to show it from a perspective of a second player, let's just say 2 as client and play, because I'm pretty sure that they do apply on multiplayer. So I'll walk with this guy, pick a weapon, go here, equip it, and now I don't know how to show it correctly, but the problem is like we don't see our hand here, but if we would see our hand, it would just rotate the wrist. But if we want to rotate the elbow and the entire hand as well, what we can do, and let's put it back to 1 standalone, it will be easier to see everything. So what we want to do, okay, ignore this one. What we want to do is go into our hand sway, and here we're not doing this anymore. And in our hand sway, instead of modifying the hand R, we are actually modifying the perfect hand R. And this one will modify left hand as well. And it will modify, like, because our elbow is trying to keep the same rotation as it was, now when we are swaying our hand, we'll be swaying our full hand. So let's just pick up a weapon. So this still works, and now we are also swaying our elbows, both of them really, not just the hands themselves. Okay, but we can see our nose. It is annoying as hell. So how to do it so it doesn't break our shadow, and it doesn't break our vision, and it doesn't break our immersion in third person for the other people who might see us, right? So how to do it? Very simple. You just go to the main character, you go into, well, wherever you go into first person, wait, did I or did I not? Event on FPP changed? No, it wasn't used. So we are by default on first person, we got only one camera. So this will be easier. We just go into begin play. So on event begin play, we have this setup unarmed. Okay, that's cool. We'll leave it as is, and we're going to make a new event, custom event, and we call it hide mesh. Okay, and we're going to say local controlled, and we're going to say player controlled, because it doesn't matter for AI, right? So if we are local and player controlled, so if it's both true, okay, we'll arrange it in a second. So if it's both true, we want to get our mesh and say show material section, and it's a bit tricky because it's same as, like, you have hide bomb by name and unhide bomb by name, but you don't have hide material section. Just show material section with show not true. And how it works is that it's making the section absolutely not render, but it is still existing as a geometry. So you can still get collision traces against it, and it still drops shadow, but it's just not being rendered, and that's it. So we go into our mesh, we go into our male zombie, and we're going to see our material sections, asset details, and what do we need to hide. It will be the tongue, the head probably, and then maybe our teeth, mouth, and eyes, but I didn't think we have problems with eyes, so let's just start with those. So we'll hide 0 and 1 just for start, so we will need it twice, and it goes for the same mesh. And we'll hide material section is 0 because we just got one actual section on the character. Like this is material slots, and there are just one section. I don't know what would have to happen to have different sections. I think it is in a situation where you have this layered material stuff, where you have multiple layers that are different materials on a material map. So this is just material section 0 and material ID 0 and 1. And now what we want to do, and show false. So what we want to do is begin play, hide mesh, and it will only trigger on our local player. Oh, okay, but we need to do it differently. We have to say that it's replicated on owning client reliably, and we need to run it on possess, because we might run begin play before we actually possess the character. So we do it here, hide mesh, and because we're running on the owning client, we only need to check not if it's local controlled, because it's always local control. We just have to see if it's player controlled, but we can leave it as is, it doesn't really matter. So hide mesh and format, thank you, it's a lot better immediately. And this, and if we hit play, we no longer see those artifacts, but if we look really fast up, we can see our eyes, and that's creepy as hell. Like, I don't mind this hair, but the eyes are super creepy. So let's hide the eyes. Let's get our character, and where are the eyes? The eyes is 12 and 13 and 11. 11, 12, 13. Well, actually it's from 9 to 13. Okay, so from 9 to 13, no problem. So 9, wait, no, this is 0, so 9, 10, 11, 12, and 13. And it all has to connect back to the mesh as well. And this way, you will see in a second, let's hit play, and let's make it full screen, so it actually takes more FOV. I can still see my hair when I look directly up. I can never see my head, but it's still oh no, it's not dropping shadows. Ooh, that's a problem. I can see the shadow of my teeth. So my mouth, oh, I probably look like nightmare fuel right now. Yeah. So how we can fix that is we actually can go, and this is also optimization for well, general how heavy this character will be. Is go here and say shadow, and say capsule direct shadow. Capsule indirect shadow is a bit messy, so I would leave it as is. I would just hit capsule shadow, and that means that our mesh, now if we go into the mesh, we need to make sure that it has a physics body, and it should also have a lighting physics body. So we need to get this one, have it here, and put it here. Save it. So now our direct shadow is being cast by our capsule, but this is the indirect shadow. Okay, so we can't avoid it. We have to do shadow and say capsule indirect shadow as well. And this is what? Oh, it's probably because I'm also having ray traced shadows. So the only way to actually do it would be add a second head mesh, which is not being rendered but does cast shadow. Okay, so this is how you make this retarget, and you can use virtual bones to store information from the animation as designed. So if the animation is designed for first person, it will have this ratio between the weapon, right hand, left hand, and head stored inside the animation, and you can imprint this information into virtual bones and use it in characters of different body proportions and different body sizes, and that will just reach out with IK into those points to hold your weapons exactly as designed. And by the way, if you would like to adjust this finger location as well, because mannequin has giant hands, he doesn't have such small hands, you would have to use just CCD IK to place them correctly with this geometry, but this is just a lot of work for very small payout, honestly. So this is something you would see in AAA games, not in just a small indie tutorial done in less than an hour. So I hope you find this useful, that you can make this character animate properly. And now I am sharing animations with mannequin perfectly, directly, and I can swap this character to any other character, and I can change his hair. I can do a lot of it. I can just add other components, clothes and everything, and they will animate with my main character perfectly, and they will also align for first person. So thank you for listening, and soon I will make more videos on that. Like, there's a lot of topics I need to cover still, like how to manage female characters with high heels, because that's a problem by itself, and how to move high heels from from DAS Studio to CC3. I will also cover how to manage capes and objects that you don't really skin, but you want them to be partially driven by animation and partially by a close simulation. And yeah, I'm working a lot of stuff doing it for games that I'm developing right now. And while doing it, I am trying to always share my knowledge and share whatever research I'm doing with you. Soon I will also post AI videos and inventory system, which will be, I think you will love it, because it's not binding you to use certain classes that I created, or it's just very free. You can use any class, any object type. You can use actors as direct inventory references, and you don't have to make some complicated structures, or you don't have to keep inventory inside a giant data table. You can just use actors in your inventory directly. So yeah, see you guys soon. I hope you find it helpful, and yeah, bye.